In machine learning applications, data comes in the form of the outcome, what we want to predict, and the features that will be used to predict the outcome. We want to build an algorithm that takes feature values as input and returns a prediction for the outcome when we don't know the outcome. The machine learning approach is to train an algorithm using data sets for which we do know the outcome, and then apply this algorithm in the future to make predictions when we don't know the outcome. Here, in this course, we will use capital Y to denote the outcomes and capital X with an index x1 through xp to denote the features. Note that features are sometimes referred to as predictors or covariates. We consider all of these to be synonyms. In the videos and the course, we try to stick to using features, but don't be confused if we switch. Prediction problems can be divided into those with categorical outcomes and those with continuous outcomes. For categorical outcomes, Y can be any of k classes. The number of classes can vary greatly across applications. For example, with digit readers, k is 10, the classes being the digits 0, 1, 2, 3, all the way up to 9. In speech recognition, the outcomes are all possible words or all possible phrases we're trying to detect. Spam detection has two outcomes, spam or not spam. In this course, we denote the k categories with indices. Little k equals 1 or 2, 3, all the way up to capital K, which is the number of classes. However, for binary data, we will use k equals 0 or 1 for mathematical convenience. We'll see that later. The general setup is as follows. We have a series of features and an unknown outcome we want to predict. To build a model that provides a prediction for any set of observable values x1 through x5, we collect data for which we know the outcome. When the output is continuous, we refer to the machine learning task as prediction. And the main output of the model is a function f that automatically produces a prediction, denoted with y hat also, for any set of predictors x1 through xp. We use the term actual outcome to denote what we end up observing. So we want the prediction y hat to match the actual outcome y as close as possible. Because our outcome is continuous, our prediction y hat will not be either exactly right or wrong, but instead will determine an error defined as the difference between the prediction and the actual outcome. When the outcome is categorical, we refer to the machine learning task as classification, and the main output of the model will be a decision rule which prescribes which of the k classes we should predict. In this scenario, most models provide a function of the predictors for each class. These are used to make the decision. When the data is binary, a typical decision rule looks like this. If f1 of x1 through xp is bigger than some constant, some predefined constant c, we predict category 1. And if it's less than c, then we predict category 0. Because the outcomes are categorical, our predictions will be either right or wrong. Notice that these terms vary among courses, textbooks, and other publications. Often, prediction is used for both categorical and continuous outcomes, and the term regression is sometimes used for the continuous case. Here, we avoid using regression to avoid confusion with our previous use of the term linear regression. In most cases, it will be clear if our outcomes are categorical or continuous, so we will avoid using these terms when possible.